30 seconds late. Nah, man. Your internet must be slow. I started perfectly on time, but you got that slow internet. Not my fault. Gotta check your connection. You got that Google Fiber? Prove it. Post screenshots of your download speed and your upload speed. All right. So, solving the equation. So, we talked about solving various types of logarithmic equations. And oops, come on, come back. I lost it. Aha. Because your Wi-Fi card is bad. Wow. See, you get the Ethernet cable. Come on. So our goal here is going to be first, well, I guess we can kind of run through our checklist of our methods that we knew. Right? This is definitely not method one, because method one is just a logarithm equals logarithm. It's not method two exactly, because I don't have multiple logarithms on both sides and different stuff going on. So I just have one single logarithm. So my goal is going to be isolate that logarithm and then use exponential. So first step is going to be subtract 3 from both sides. Great. So minus 6. There's a negative here on both sides, so I'll get rid of that. Okay, so now this is something we didn't see yesterday, so I thought I'd throw it at you here, is that I have this 6 in the exponent of the logarithm. Remember that one of our properties is that we can take an exponent and bring it down as a coefficient. All right, so that'll make my life a lot easier in that I can now just divide everything, divide both sides by 6. So I have log base 5 of 4x minus 11 equals 1. Now, what do I do with this logarithm base 5? Well, I get rid of it by using its inverse, which would be an exponential base 5. So I'm going to create a base 5 on both sides. And everything that was originally in the equation gets shifted up into an exponent. Exponential base 5, logarithm base 5 cancel each other out. Five to the first power is 5. And now just two-step solving. 4x equals 16. X equals 4. Smooth. Okay, hopefully we feel pretty good about that. So we had to use a little property there to move that 6 from an exponent down into a coefficient, just to make my life easier. Divide by 6. Okay. Oh, wow. I blew it. Oh, that sucks. I meant to clear out that stuff too. I guess I didn't. Whatever. It's just less for me to write down, less for you to write down. Okay, so we're going to talk about our applications. Yeah, it's Wednesday. We have early release today. That's so true. So we got to go quick, you know? We got to go quick. Don't have much time. So we're going to talk about applications that we can use with logarithms. So a couple that are pretty relevant and pretty common things that affect us. So the first is the Richter scale, which we know the Richter scale measures earthquakes and how intense they are. And so the formula is that purple equation, right? M equals log of I over I-O. Right. So that first I, the capital I that's on top, is just the intensity of the earthquake. And the denominator, the I0, is the intensity of what we call the threshold quake. Now, the threshold quake is like the smallest detectable earthquake that there could be, right? Because I don't know if you've ever seen a Richter scale, like a readout. It's like, that the arm that like scribbles back and forth, and whenever it's a really big earthquake, then it scribbles really wide or, smaller, things like that. So that's measuring, kind of the quakes in the ground, the waves in the ground. And so at a certain point, there's just, the ground is always, moving a tiny bit, but at a certain point, we can't measure it anymore. So the I0 is just, okay, this is the smallest amount that we can actually measure. And so we'll compare other earthquakes to that smallest amount. Right? So Richter scale. M stands for magnitude. We always talk about the magnitude of an earthquake. And then the other option is decibels, right? Measuring sound. So if I remember from college algebra, it's always common log, right? Yes, both of these formulas, they use common log. So the base is base 10. Yes. So the decibels formula and the Richter scale formula are almost identical. The only difference is that for measuring sound, the decibels has 10. Okay, that coefficient of 10. But for the Richter scale, there is no coefficient of 10. That's the only difference. Right? But it's still, so the capital I in the numerator is the intensity of the sound. And in the denominator, the I0 is the intensity of what we call the threshold sound. So the smallest detectable sound, right, for us. So even though, again, sounds are also, so just like earthquakes are measured, in the ground because of their waves, sounds are sound waves that our ear, travel through the air, and our ear recognizes and changes into what we hear as sound. And so at a certain point, though, there are things that are quieter than we can hear. So we say that I0 is just the threshold sound. It is the smallest detectable sound that, measuring anything less than that has no meaning because it's undetectable for us. Which is a lot of things for me because I can't hear very well. Come on. All right, just a quick table here, just kind of some interesting. The Richter scale is measured, starts at 1, goes all the way up to 9. I can't stop being old, man. This is just my life. I'm old. I am old. And so usually we talk about the Richter scale in like something between 1 and 9, and then usually one decimal place, like 3.4, 5.6, 7.8. There was just an earthquake earlier this week or last week in what was it? Like Salt Lake City, I think. Which was like it wasn't an immensely terrorizing earthquake, but it was, it did some damage. It was weird. People thought that was going to be really bad because Salt Lake City has been waiting for a really, really big earthquake for a long time. And so I think a lot of people thought that was going to like completely destroy everything. But this one wasn't that bad. So they're still waiting on that big one. But you can see the frequency on the column over here of how frequently they usually happen. Once you get into the major earthquakes, like the 7s and the 8s, those happen very, 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 very infrequently. Okay. And especially 9.0s and greater, that's, very uncommon. Right, but every now and then you hear about those big ones. Okay, so an earthquake is 179,000 times more intense than the earthquake threshold. What is its rating on the Richter scale? Okay, so 179 times more intense than the earthquake threshold. So the intensity, so 179,000, but it's not saying the intensity is just 179,000. It says it's 179,000 times more intense. So times whatever the threshold is. So our equation of I over IO then just becomes 179,000 threshold. So we just made a direct substitution here for that capital I in the numerator. The I0 and the I0 will cancel. So log of 179,000 is the only calculation that we need. So let me pull up my calculator here. So log, so this is common log, so we can just click the log button. 179,000, 5.25. And again, Richter scale, earthquakes are usually measured in just tenths. So we'll say the magnitude of this particular earthquake is 5.3. Everyone comment in the chat what your favorite earthquake from history was. Right, so it was just plugging in, cancel the IOs, fine, do the logarithm. Let's take it to decibels. The one that's about to happen. Why are you here? The one that's about to happen. Yeah. 1906, San Francisco. That was a good one for sure. It really rocked the house. A conversation 89,000 times more intense than the sound threshold. How many decibels is the conversation? So the intensity of this sound is 89,000, but not just 89,000, 89,000 times more intense than the threshold sound. So times I0. 1960 what is this? Valdivia? Valdivia? What country is that? Is that Italy? I don't know. Sounds like a good one, though. Chile. Oh, okay. Okay, so our formula, right? Remember, this one has a 10. Yeah, this is math analysis right now. The office hours starts at 1:45. No problem. You're good. Hanging out, learning good stuff. So again, we'll make our substitution. Instead of the I in the numerator, 89,000 times the threshold divided by the threshold. These will cancel. So this just turns into 10 log of 89,000. So let me do that real quick on my calculator. So we have about 49.5 decibels. I need to get sponsored by Web 2.0. Yeah, I'll work on that. Maybe. I'm looking to get sponsorships from Web 2.0 Calculator, Desmos. Still continuing my Hy-Vee sponsorship. That one's going really well. You know, just we're seeing how it all works out. Got a lot of agencies contacting me about wanting to work with me because of my high volume stream. All right, so those are just the basic calculations on if we know the intensity, great, plug it in and get the actual rating for the earthquake or the sound level of the decibels. But if we want to mix it up a little bit, so how many more times intense is an earthquake that registers 7.1 than an earthquake that registers 6.3? Okay, so let me just write down here. Earthquake 1 is a 7.1. Earthquake 2 is a 6.3. So this question is not asking what's the difference between them, right? The answer to this question is not 0.8, right? That's the difference in the magnitude, right? It's 0.81. But the question is, how many more times intense, right? The intensity. So it is useful for us to know the difference in the magnitude between them. So if I do a quick, I already said it. But so this is the difference in the magnitude. What am I writing? So if I want to compare the intensities, what I'm going to do is I'm going to use my formula. So log of, and what I'm going to do, instead of I and IO, I'm going to say the intensity of the first earthquake in the numerator and the intensity of the second earthquake in the denominator. So this will compare the two earthquakes. Whenever we use the original formula, this because I and I0 are in the logarithm, it's comparing whatever the earthquake is to whatever the threshold is. Right? But the point is we can actually choose anything to compare together, or any two earthquakes, if we put the intensity of one of them divided by the intensity of the other one. So we can use it to determine comparisons between earthquakes. And I'll set that equal to 0.8 because I know 0.8 is the difference in the magnitude between them. So whenever I compare the two earthquakes, the difference in magnitude is 0.8. So let me solve this now to end up with the ratio of the intensities. This is just a logarithmic equation. This is what we worked on yesterday on how to solve this. Well, I need to get rid of the logarithm. So inverse of logarithm is exponential. So I'm going to create an exponential of base 10. And I use 10 because this is common logarithm, and common logarithm is always base 10. And then everything that was in the equation originally gets shifted up into the exponent. The exponential base 10 and logarithm, common logarithm, which is base 10, cancels. So on the right, I just have what was originally inside, intensity of earthquake 1 divided by intensity of earthquake 2. I'm going to real quickly on my calculator do 10 to the power of 0.8. .31. It was 309. I rounded up to 31. Okay, so 6.31. Now again, keep in mind of what this actually means. This is what we get if the ratio between the two earthquakes, right, intensities. Intensity 1 divided by intensity 2 is 6.31. So what this means is earthquake 1 is 6.31 times more intense than earthquake 2. Because when we solved, the ratio between them is 6.31. So that means that first earthquake, the earthquake in the numerator, is 6.31 times more intense than earthquake 2. Okay. Next one. A motorcycle is 95 decibels and a lawnmower is 65 decibels. How many more times intense is the sound of the motorcycle than the lawnmower? Okay. So again, let me just write out. Motorcycle, 95. Lawnmower, 65. Also, the earthquake in Chile is 9.5 on the scale. Yeah, that's wild. That's horrifying. I can't even imagine. Okay, so then it's another question where I'm trying to find how many more times intense. Okay, so the first thing that I need to do is figure out what is the difference in decibels between them. So not too wild to do. 95 minus 65. So there's a difference of 30 decibels. But how does that translate into intensity? So we'll do our same thing. So here's our normal formula we would use for sound, 10 log. But instead of comparing just one sound to the sound threshold, we're going to compare two sounds to each other. So intensity of the motorcycle divided by the intensity of the lawnmower. All right, and you can use whatever, those little subscripts, the letters down there, you can use whatever you want. You could just use 1 and 2. You could use letters to whatever. It doesn't matter. And so I know whenever I compare those two earthquakes, when I compare their intensities and run it through this formula, the difference between those is 30 decibels. So we solve. First, this is just a logarithmic equation. So first divide 10. So 3 equals log of the ratio of the two intensities. Get rid of logarithm by doing a base 10 exponential. Right, so the base 10 exponential would cancel the logarithm on the right side, so that I get 10 cubed, which is 1,000. So what does that actually mean? So when I compare the intensities, the ratio of them is 1,000. So the intensity of the sound of the motorcycle is 1,000 times more intense than the lawnmower. Okay. Next example, so still sticking with sound, a blender is 60 decibels and is 63 times more intense than a phone ringing on high. How many decibels is the phone ringing? All right, so this is another different style of question. I'm told the decibels for the blender but for the phone, I don't know how many decibels. That's what I'm trying to figure out. And the only other piece of information I know is that the blender is 63 times more intense. Okay. So I will write, sorry, speed mark. Oh, okay. Right. So it tells me the ratio between them already. It says, hey, the ratio of the blender to the phone is 63. So let's use this in my formula, so 10 log, so the intensity of the blender compared to the intensity of the phone is 63. And so that would be equal to the difference in decibels. I can just write dB because I don't know how to spell decibels. It's too hard. And so this is just a calculation I can do. Decibel, yes, thank you. I know how to spell decibels. But I'm too lazy to write decibels is the real issue. So let's just type in 10 log 63. So that equals 17.99. So I'm going to round that up to 18. So again, remember, what does this actually mean? It means the difference in decibels between the two sounds is 18 decibels. All right, so I'm not done here just by solving for 18. That's a good start. But I either need to move up or down, right? 18 is the amount of change between them. Right? So 60, the phone is louder, or sorry, the blender is louder than the phone. It tells me that because it says that it is more intense. The blender is 63 times more intense than the phone. So I'm going to take 60 decibels, subtract 18, so it must be that the phone ringing on high is 42 decibels. Again, feel free to jump in at any time with some questions. All right, last one, I think. Yes, last one. Earthquake 1 5.0 and is 141,000 times less intense than Earthquake 2. Earthquake 2, I don't know what the actual rating of it is, but I do know when I compare their intensities, Earthquake 1 is 141,000 times less. Or another way of thinking about that is Earthquake 2 is 141,000 times more. Okay, so I'm going to put intensity 2 on top. All right, I think you don't necessarily have to, but it would change it and you'd have to do it differently. I think it's easiest just to keep the intensity of the louder thing or of the higher thing on top. Keep it in the numerator. I think that's the best way to go about it. So since Earthquake 2 was a stronger earthquake, I'm going to put that in the numerator. So if I compared them, I would see that the ratio between them is 141,000. And so using my formula, if I calculate log of 141,000, this would equal the difference in magnitudes of the earthquakes. Right, it won't give me the actual answer of what is the rating. It gives me the difference, the change between them. Right, since we compared earthquake 2 to earthquake 1 for our ratio, then the answer we get is the change in magnitude between them. So let me calculate really quick. Log 141,000. So that equals 5.2. Again, for earthquakes, we round to the second decimal place. Or sorry, 5.1. Yeah, it would be 5.14. So that just rounds to 5.1. Right, this isn't the answer. This is the change between the two earthquakes. So since earthquake 2 is stronger than earthquake 1, then that means I'm going to take earthquake 1's magnitude, which was 5.0, and I'm going to add 5.1. So this is the magnitude of earthquake 2. That's a big earthquake. That is true. That would be total annihilation. Remembering from college algebra. Good, good, good. Okay, so there's three main setups here. So I kind of organize it as such. These first two questions are just calculate the rating. Either find the magnitude of the earthquake or find the level of decibels, just purely plugging into the formula. But from there, we have now problems that are, we know something is this many times more intense. So, or sorry, we know the two earthquakes magnitudes, and we want to find out how much more intense. So that was what these next two problems were. Right, find more intense, find more intense. And then our last two problems were, if we know the comparison of the intensity, and I know one of the decibels, or one of the magnitudes, can I then find the other? Right, so there's 6 questions total from these notes, and it's split up 2, 2, 2. First two are just the basics, plug in, calculate. Second one is find the intensity, the comparison of the intensity between them. Third one, use the intensity and one of the ratings or decibels to then find the other rating or decibel. I sent you a homework assignment on this. Please do it. It's not super long. First page is just practicing some logarithmic equation solving, and then the second page is just like 4 or so of the earthquake problems. All right, and some of them go pretty quick. So please do practice those, because again, you're gonna have to do it on the PFA. Gonna have to do it on some sort of, or so our project that we're gonna do here in a few days or at the beginning of next week. So make sure that that's something that you're comfortable with, because we're going to have to do it. Of course, email me with questions or stay here for my office hours stream here